I once had a dream of living entirely green, but my year of living green quickly became a costly nightmare as the reality of living on 100% renewable energy proved harder than I thought. There's a reason that despite over 40 years of developing renewable energy to prevent the known dangers of climate change, fossil fuels still account for the vast majority of energy consumption. Sadly, the low energy returns of electricity from solar and wind can't sustain, let alone grow, the global economy. Their current limited use is entirely dependent on fossil fuels for their manufacture and for backup power due to their intermittency. There are only enough lithium reserves to replace about half of today's cars with electric vehicles. And recycling rare earth metals would just lower energy returns even more. So green transportation would require biofuels or hydrogen fuel cells. Either would create an unsustainable drag on energy return as a replacement for oil, which makes up a third of world energy consumption. Nuclear doesn't have sufficient energy returns or uranium reserves to replace existing power plants for very long. While hydroelectric does have sufficient energy returns, like geothermal, it's limited to specific geographic areas, so neither can provide a global solution. With an overall energy return of just 5 to 1, the dream of green growth with clean energy is an unattainable fantasy. There wouldn't be enough surplus energy to run the world on renewable energy, let alone grow it. And there certainly wouldn't be any surplus energy left over to also remove carbon dioxide from the atmosphere by technological means. Remember, it's no longer enough to simply stop emitting carbon. We actually have to remove some of the carbon we've already put into the atmosphere. Technological methods to do this are too energy intensive, especially with low surplus energy green sources. And using fossil fuels to remove carbon ends up putting more carbon into the atmosphere than is captured. Natural methods to remove carbon, like planting trees, is simply too little too late, especially now that wildfires have begun to accelerate. No amount of efficiency gains can overcome the fundamental physics of entropy, which is at the heart of low energy returns for renewables and high energy costs for carbon capture. Collecting disparate sun and wind energy over the course of a single day will never yield the same energy returns as easily accessing the millions of years of sun energy concentrated by geological forces into fossil fuels. Similarly, removing carbon from the atmosphere is like opening a bottle of perfume and then trying to capture all the scent molecules in the air to put them back in the bottle. Could it be that humanity's pursuit of infinite growth on a finite planet may finally be reaching its limit? If so, then could we change course and scale down society? Perhaps intentionally making it less complex and able to function despite lower energy returns?
Oh, well, hello, Phillise. I am so honored to have you as my guest. Welcome, everybody in the chat. I am Sandy Shellis. This is Environmental Coffee House. And Phillise, welcome. Welcome. We are,
Thank
people are
you.
growing in the chat. And I chose that. Phillise has a wonderful YouTube compilation of videos, which I'm going to show you really quick before I turn it over to her. And I chose one of them, but she has personal reflections on humanity's predicament, and it's a bunch of excellent videos. Just short and sweet and very understandable. And I found you, Phillise, because you commented on the channel, and your comments were always like spot on. Fantastic comments that spurred some discussion. So welcome, Phillise. Welcome.
Thank you. Thanks for having me. Thanks for inviting me. I love your show. I love seeing all of you guys sort of keep everyone abreast of what's going on as climate change, all the news unfolds. So I think that's fantastic. So I'm so excited to be here. Thank you for having me.
Oh,
Yeah.
awesome. Well, I think we're going to start out. I'm actually going to give you the floor today to talk about, well, I know that we had a conversation on adaptation. We both are parents, and we think about the fact that, we're here now. We may be here for however long. What are we going to do? And I think you are the perfect person. But first, tell us a little bit about yourself and physics and your, where you teach, and just who are you, Phillise?
Sure. So, yes, I am a physics professor in Washington State at a college in Washington. But prior to being a physicist and getting my Ph.D. in physics, I actually had a career in finance on Wall Street. So my first undergraduate degree was in economics, and I worked on Wall Street, and then I went and I got an M.B.A. And then I decided to leave sort of corporate finance to do something more rewarding, which was teaching. And that's when I got a second bachelor's in physics and the Ph.D. as well. So that's sort of my background. I am not specifically a climate scientist. That was not where I specialized. I specialized in theoretical quantum physics. However, I think it was around 2018 when the IPCC report came out. That big report, the 1.5 report came out. Yeah. And that's really when everyone started talking about climate change. What's happening, what's going on. And I remember I was putting together a new course at the college. And we always teach about climate change, but we just basically teach about the science, the chemistry, the science, the atmosphere, the thermodynamics. I never really took a look at where are we in the story of climate change, how far along are we, what is the timing, what is the magnitude of everything. So I was putting this course together, and so I took a look at the IPCC report. I think like most people, I kind of assumed that climate change, it was a way off problem. It was something far off into the future. I had no idea the scale and the magnitude. And, in the news media, when they talk about climate change, they talk about things like, the poor polar bears not having a home and sea level rise, right? And while these are significant issues, definitely, it doesn't necessarily put the fear of God in people so much as when you hear things like human extinction, right? Yeah. And I had no idea that was on the table with climate change until, around that time. So prior to that, I had been studying sort of energy issues. I was interested in, I'm wanting, I know a lot about investing, obviously, but after the Great Recession, I was like, I think there are some real systemic problems in the market. I want to look at this more closely before I start committing my own money into the stock market. And that's what led me to studying energy issues and issues around peak oil and biophysical economics. Wow. And so I had that background when I started looking at climate change. And so when I read the IPCC report, the 1.5 report, and I saw the IPCC's plan, which was that we should have our emissions by 2030 and then eliminate them by 2050, and that was what we had to do starting in 2020 at the latest. We had to start reducing those emissions, or else we would tip into a runaway global warming. So when I read that, I was I was completely shocked in a way I don't think most people were, because I knew that that plan was impossible based on the
Right.
prior research I had done on energy returns and peak oil and all of that kind of thing. So I was pretty shocked. I was pretty scared. I was in denial. This can't be real. This can't be happening. So I went through all of that and I processed all of that. So that's where I am now. I did the video series. There have been some new developments, so I'm
Oh, yeah.
happy to share some of those things with you. Some good work from some other people have come out. So, uh, yeah, I'll just hand it back to you for just a
Well,
moment, and
we are
then
ready.
let's see.
We are ready.
You're
This is,
ready.
yes, you have
Okay.
a very exciting background. And
Okay.
bringing someone with your knowledge, skills, and abilities is really interesting. And especially for our audience chat, who are always asking me about things like, quantum physics and physics. So we'll see what the questions are that come up later after you talk about. But did you want to start out talking about what we had talked about a little bit, the background of, well, being that there's so many people with kids in our audience, and now that you've learned what you've learned, what do we think? You have kids, I have kids, about the adaptation to the future, degrowth. Where would you like to start in your head where all this comes together for you?
Right. Well, so when we spoke, I did some work last night and I sort of put together sort of
Yeah,
all the latest and greatest information. And
perfect.
I'm really sorry to say I don't have very optimistic news. I wish I had more
Okay.
optimistic news. Now, I'm not quite as doomer as maybe Guy McPherson. This won't be a Guy McPherson lecture.
Okay.
We love Guy, but I'm
Yeah.
not saying that
But
everything is going to end
we love Paul
immediately.
Beckwith.
And we love Paul Beckwith. I'm going to
Yes.
mention him as well. I think I guess what I'm going to start with is that I'm not going to start with what I wish is going to happen or what I hope is going to happen
Yeah.
or what I even think should happen morally and logically. I'm just going to lay it out there and let's just have a frank conversation
Lay
about
it
what is
out.
actually going to happen. Because I think if we don't face what's actually going to happen and we keep having these conversations around, oh, well, we have the solutions and all we have to do is push the governments to implement the solutions. I mean, if we keep perpetuating this conversation and we don't face what's actually coming, then how can we have any hope of adapting? I mean, I would imagine that our
Right.
adaptation strategy is not going to be as good. I would imagine that the thoughts we have about preparing for our own retirement, setting our children up for future success, how can we really have a reasonable plan for that if we don't actually face the hard truth about what's coming? All right.
Yeah. Yes, we try to face this here, but we also try to have this wide discussion, which you well know because you follow us under this environmental umbrella. And I also like the fact that you said, well, your video's 11 months. A lot changes in 11 months. Wow. So there you
Exactly.
go.
So I'm just going to tell you where I'm at with all of this,
Tell
and
us
then
where
I want
you're
to hear
at.
from I want to hear from everyone else. And
Yes.
if you have questions or if there's other information that other people have, let's go for it. Okay,
And they
I
know
have
to
a
put a
lot of
Q in
information.
front.
So
Yeah. Q,
okay,
two
so
Qs.
we'll see how far we get. Okay, so I do have a prediction. Okay, and my prediction is that we are not going to curb our carbon emissions anytime soon. That the only way that we are going to curb our carbon emissions is if one of two things happens. The first thing could be that the fossil fuels that's currently in the ground,
Yeah.
it just takes too much energy to get it out than the energy you get. So here's where the concept of energy return comes in, which I talk about in my videos. And I think this is a concept that most people really don't understand. And we have to understand this, especially when we're talking about the prospects for renewable energy. So let me just explain really briefly, okay? So let's say you want to pump a barrel of oil out of the ground, and you're going to use, you remember those dinosaur oil drills,
Yeah.
just
I read all the
imagine
peak
that,
oil.
right?
Yeah. Uh-huh.
Right?
Yep.
Okay. So just for people who aren't familiar with peak oil or energy return,
Mm-hmm.
that machine to pump the oil out of the ground, it uses energy. So let's say you use a barrel of oil to pump that machine and you only get a barrel of oil back. Well, clearly that was a useless exercise because you basically spent the same amount of energy that you got back. So that's an energy return of 1 to 1. Okay. So you need an energy return of greater than 1 to be able to, once you pump the oil out of the ground, refine it into gasoline. You need an even greater energy return to be able to transport the oil somewhere, to a gas station, or to refine it and transport it to a gas station. A society needs more energy return on its energy to have an agriculture industry, to have economic activity like research and development and the creation of new technologies and all of that. You need this energy surplus in order to have that. Okay. And so I will reference, if you want to learn more about that, I recommend looking up Charles A.S. Hall. He's the one who coined the term, and he has some good papers about that. He estimated that for our global industrial society, we need an energy return of about 14. Okay. 14. And you have to, keep 14 in mind, because when we discovered oil, or at its peak, let's say, energy returns were like anywhere up to 100 to 1. So everything you see around us, all the society that we've built, was based on the surplus energy. You put in 1 barrel and you get back, 100. Okay, that's a great energy return. Okay. The problem is that renewable energy, well, let's just talk about fossil fuel energies. That energy return is going down and down and down.
Yeah.
So conventional oil, like you have, say, in the Middle East, is much less now, 50, 35 to 1, depending on the estimates. But the main thing is that the growth in oil production has come from U.S. fracking. Everyone's familiar with fracking. The problem with fracking is the energy return there is about 5 to 1. It's a very unprofitable business and industry. So energy return, even for fossil fuels, is going down, 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 so that the world average is just about at that 14 to 1.
Okay,
which is why.
I got one question, and I hate to interrupt you, but can ask Jean, ask her to say that again, 1 to 14. Just go over that little bit again. This is kind of like a class.
Yeah, absolutely.
Thank you.
I'm referencing Charles Hall. They estimated that our global industrial civilization requires an energy source of at least 14 to 1. But keep in mind that everything that we've created, all of our technology, all of our agriculture, the entire population of the globe, all of our cities, that was built on much higher energy returns of at one point 100 to 1. Energy returns for fossil fuels have started to fall. And as they start to fall, what happens is, I won't go into too much of the economics because I want to stick to the climate change, but you start to see stagnation in the economy. All right. So there were, if you're familiar with peak oil, that's just what happens with an oil field. When you discover the oil, your production increases until it hits a peak. And then it starts to decline, sort of like a bell curve. And what happens to oil fields happens to countries and happens to the world.
All right, Jean. I think she might. Thank you, Phillise.
Okay, awesome. Okay. So why is this sort of important? So what I was saying is that, as long as it takes less energy to get the oil or other fossil fuels, we're still going to be getting it.
Yes.
And I'll explain why in just a little bit. The only other thing that would stop carbon emissions from going up is, again, some sort of environmental collapse where society just collapses to the point where we literally can't extract the oil. There just maybe aren't enough. There's not enough food. There's not enough food to feed the people, the workers, the society, the supply chains break down, and global catastrophe. So that's my prediction, is that sadly we're just going to keep going up and up and up. So why can't we save ourselves with renewable energy? There are a number of reasons. The first reason is that green energy, particularly solar and wind, has an energy return of around 5 to 1. Okay, so the idea. A lot less. The idea that we could support global industrial civilization with an energy source that has such a low energy return, the physics do not support that. It's sort of like, imagine you had a whole power plant of solar panels, and all the power from that power plant was used to manufacture more solar panels and more batteries. And solar panels have a life of about 30 years, batteries a life of about 15 years. So let's just say 15 years, just to keep the math simple. And let's say you spend 15 years producing solar panels and batteries, and then at the end of that time, you only made enough solar panels and batteries to replace the solar panels and batteries that are now being decommissioned. So all the power that you created just went towards making more power by the time you need to replace it. Now that's an exaggeration. That would be an energy return of 1 to 1. But you see what I'm saying? It's only the surplus energy that allows you to be used for economic activity, for agriculture, for all the commerce, everything. So any questions on that so far?
Anybody out there? No cues. So keep going. This is great for me too.
So, so the idea, so a lot of people will say, okay, well, what about degrowth? Okay, why do we have to sustain global industrial civilization? Why can't we collapse it? Why can't we make it something smaller, right? Well, think about what you're asking for. When you ask for degrowth, what you're really saying is a shrinking of the economy. What is a shrinking of the economy? It means negative GDP growth. It means a decline every year of GDP. That's what it means. It means the number of, what is GDP? Imagine all the sales of goods and services. If you collected the receipts and just added them all up, that's the gross domestic product. That's all the commerce. That's the economy. Okay. So when you're asking for degrowth, what you're asking for is perpetual recession, AKA a permanent depression, where every year you have less and less of an economy. You have less and less GDP. So more and more people will be losing their jobs every single year. And because people aren't self-sufficient, they don't know how to go out and hunt and find their own food or grow their own food.
Where I live, we do.
People, that's some people do. But for most people, if they lose their job, it's like they're losing their livelihood. And also as the economy, another important point is as the economy shrinks, as the amount of sales shrink, your tax base shrinks. So the amount of tax revenue the government has shrinks, and the amount of revenue they have to fund green energy transition, social programs to support workers that have been displaced. There's no more tax revenue for that.
Nobody ever thinks of this.
No one ever thinks of this. No. So you have to really take a big picture. Let's talk a little bit about what would be required for degrowth. You would have to get buy-in from voters. And I think David Wallace Wells mentioned that, we don't have to convince people who don't believe in climate change, because the majority of people, 70% of Americans and even more abroad, believe that climate change is a problem. They believe that it's human caused and that something should be done about it. And I'm thinking, okay, well, the vast majority of people think that, but they're not voting that way, right? They're not necessarily consistently voting for governments that are promoting climate change policy. So why is that? Well, if you look at it, you can kind of predict elections based on how the economy is going. People vote.
It's all about the green, baby.
And it's more, I think it's I don't even think of it as greed. I think of it as just individual families who might be struggling. They're going to vote based on a sense of fear, sense of their own prosperity, and if they feel like things are going in the right direction or not, economically speaking. So telling people, trying to sell, and so here's the mistake, this idea that we're going to have a Green New Deal, it's going to increase growth. We're going to be able to subsidize not only the green transition, but also subsidize workers who are displaced from the transition. If energy prices go up, we'll just print money and subsidize that. We're going to, those subsidies have to be based on economic growth, and you're not going to get the economic growth with energy that has such a low energy return. Okay, so that's the physics of it. And I don't think any government that implements policies, say we get a Green Party in and they're like, oh, we're going to do the Extinction Rebellion plan and we're going to switch to renewables immediately.
Yeah, sure.
If the economic growth doesn't come, okay, and anytime energy prices rise, that's going to trigger a recession. It's going to trigger, because everything costs more. It costs more to make products. And so that triggers a recession. And so voters are just going to vote them out the next election. They're not going to agree to austerity. So, another idea is, well, we can educate the public. I think that's what a lot of activism is right now. It's about, educating the public, trying to change hearts and minds to not only push for renewables, but also push for degrowth. Maybe we can convince people to accept falling standards of living, that we need to consume less, we need to do less. To that, I would say, the pandemic, I think, was a really good lesson in trying to educate the public, right? I mean, look at how trying to educate people on wearing a mask and getting vaccinated, look at how that went.
Simple things.
Yeah. And that was a simple lesson, right?
Yeah. Yep.
Yeah, like, hey, you guys, there's a virus that could kill you. Maybe cover your mouth and nose so you don't breathe so much of it in, so your body antibodies can catch up to the virus and kill it. Like, that's a pretty simple lesson, but it just,
It became extremely chaos, controversial for what? I don't know, really. It was, but I'm not here to commentate on that.
Yeah. But I'm just saying, let's realistically think, do we really think that we can get the public to support governments and consistently elect governments to enact policies to degrow, and so that we can consume less and we can reduce our standards of living? Just ask yourself, if you really think that that can happen and you want to maybe devote your time in your life to advocating for that, that's fine. But everyone has to make a choice on where they feel, how likely they feel that is going to be.
Right. What is their choice to do in this predicament?
Right.
Mm-hmm.
Right.
At least educate to give them a choice.
Yeah. So I think I talked about, the Green New Deal. There's a lot of push towards this idea that, capitalism is the problem and socialism is the answer. And I just want to address that for a minute, because, again, whether it's capitalism or socialism, the difference there is who gets what percentage of the profits, right? When we have a left-leaning government, the net consumers are taxed less, investors are taxed more, businesses are taxed more. when a conservative government is in, it's a little bit the opposite, but that pendulum only swings a little bit in either direction, because if you tax the consumers too much, they revolt. If you tax the businesses too much and there are no profits, then, you know, there's no investment in your country and they go somewhere else. So there's not much room that you can do there. It just, the taxes just kind of shift a little bit. But the point is that whether it's socialism or capitalism, you're taxing the profits. The benefits are coming from the profits. So all the social programs that we want with the Green New Deal, with just healthcare for all of those things. I love AOC. She made this, I love her passion and just her vision. I just do. But she said one thing, she's like, you know, America is the richest country in the world. Why can't we, you know, have universal health care? And I totally agree. But at the same time, I understand what pays for that health care. I understand what makes us the richest country in the world. It was oil. And it's the fossil fuels. That's where the surplus energy is, where the profits come from that you can tax, that you can then fund social programs. So we just need to keep those things in mind. Sometimes another idea that's sometimes put out there is this idea of the circular economy. Sort of like a steady state economy, a circular economy where everything is sort of recycled and, you know, that sort of thing. Not going to go too far into that, but it's kind of a violation of the laws of thermodynamics. Because every time you recycle a raw material, it degrades, right? Every cycle, there's less and less and less of it left. And so the engine that keeps the cycle going requires energy inputs from outside. You're always going to still need to keep extracting from the environment. You're going to keep having to extract from a finite planet. There's no way around that.
No doubt about it.
Yeah. I mean, yeah. So, okay. So another question people have is, well, what about efficiency gains? You know, maybe we could, you know, increase the energy return for renewables and make it comparable to fossil fuels. And I'm not going to go into the math of it, but that's not going to be possible. And a high-level way of understanding it is that you have to understand that they're fundamentally different energy sources, okay? So when I talked about extracting energy from the environment to do work, right, and then you create waste energy out, the key thing here is that the energy that is usable for work is really concentrated. Think of the sun. That's concentrated energy, and that's what's all the energy on life is coming from. Fossil fuels, you know, the plants, photosynthesis, that became the fossil fuels, and even solar, wind. It's all the sun. That's a concentrated fireball. That energy is dispersing, and once it dispersed, it's used. It's gone. It's not really useful anymore. So you need a process of collecting that energy and concentrating it. So when it comes to fossil fuels, nature did that for us, you know, the photosynthesis, the geological forces, gravity, it did it all. And we've got this really dense concentration over millions of years of sun energy stored up that we basically burned in about 200 years. We burned through in about 200 years. So that allowed us to exceed our daily sun budget, our daily budget of sun. So now we're saying that we want to build solar panels to collect all this sun energy. So we have to harvest this disparate energy. We have to concentrate it ourselves. So now it's not the geological forces that are doing the work to concentrate it. We're doing that work. And then we have to put it into a battery, and there's energy loss at every step of this. So you can kind of logically see how that is an energy flow that we are capturing and doing work to concentrate, and that takes a lot of energy to do that. It's a lot easier to just dig something up out of the ground that has been concentrated for you over millions of years. Gotcha. So that's why that energy source the flows of solar and wind are never going to compare, even come close, even with small efficiency gains. And this is really what everything I'm talking about renewables is really what Michael Moore and Jeff Gibbs, their film Planet of the Humans, this is what they were trying to get at. And the critics just criticize like little details like, oh, those are 10-year-old solar panels and we've got more efficient solar panels now, so you're wrong. But they completely miss the point. And I think the point can be better framed when you think about thermodynamics, which is a law of physics that we cannot escape, and the thermodynamics of renewable energy is clear. And I think if I was so excited when that movie came out because I thought, finally, the mainstream, we're going to have a mainstream conversation about the real issue here, you know, and we're going to be able to move past these stories of selling people green growth and you're going to have this great socialist utopia society with solar panels and wind turbines and everyone's going to flourish and we're all going to be prosperous and it's going to be great.
Yeah.
So I'll pause there for just a minute in case you wanted to comment or check to see if there are any questions.
It's all makes sense, and we've all been talking about this for a while. When that movie came out, same thing. I don't know if I thought that it would be taken very well. I didn't. I thought perhaps there would be a few enlightened souls out there in the mainstream media, but for the most part, no. And I also want to see what you guys are doing out there. If you have questions, remember to put the cues in there. This has been fascinating for me. It's a review to a point, but I'm also learning. I always pick out something new to learn. And so here we are with the conundrum of, all right, green energy. And
so that you said that was definitely review. I do have some news. So now I want to bring in some new information. I was going to just mention also the energy crisis in Europe. You know, that is partially because of the attempt to move to wind, and then the wind stopped and they didn't have sufficient battery or backup. And, you know, there's an issue with, batteries. We don't have the proper storage. So I don't even know when people talk about that we have all the technology to make this green transition. We don't have electric shipping or airplanes or cargo trucks. I mean, so anyway, but one thing that is new, I want to mention physicist Dr. Tim Garrett.
Yes.
He had a video last year on Jevons paradox where he discusses a paper that he recently did in collaboration with two economists. And this is a really pivotal moment because economics at its core is really thermodynamics. And so Dr. Garrett is an expert in thermodynamics. He's a climate change scientist. So this is a really pivotal paper. And he found some really, really interesting things. And he's made some interesting predictions. One of the predictions is that renewable energy will not displace fossil fuel energy, but it actually will accelerate resource extraction from the environment. It will accelerate our trajectory because what it does is it just adds more energy to the consumption pot. So we want to say to the public, hey, here's some great renewable energy, use this, don't use the fossil fuel energy. But what ends up happening is the public says, oh, great, we'll take both. Thank you.
Well, that's what's going to happen because that's what they talk about. It's like incrementalism in politics. It's going to be incrementalism to get off fossil fuels, but to build everything that's green, like EVs. Today, for example, I'll just go really quickly. Senator Schumer here in my state came to Western New York, and he told General Motors workers here that they are going to get an infusion of money and jobs to build EVs. And of course, my first thought is, well, what's going to power the assembly line? What's powering all of the manufacturing? I mean, it's just business as usual, just rearranging the deck chairs again. But that's it.
Yeah. No, exactly. And that's another thing that he alludes to is he says that before we started going big with expanding renewable energy, he says that the growth in carbon emissions was decreasing. So carbon emissions were still increasing, but the rate of growth in that increase was decreasing. That changed once we started manufacturing a lot of renewable energy because, again, it takes a lot of fossil fuels to manufacture the solar panels and the batteries, and the plastic blades of the wind turbines are made of fossil fuels. So, and all the metal extraction and all of that, it actually increases the demand, not just for renewable energy, but also the demand for other forms of energy. I like to think of it, he uses a snowflake example. I like to think of it a triangle example where one side is renewable energy, the other side is fossil fuels, and the bottom is just resources like metals and all the resources from the earth. And as you expand one side, meaning the triangle gets bigger and bigger and bigger, you think you're only expanding one side, but because it's an interconnected system, you end up expanding demand for everything. You just end up expanding all of it. Yeah. So that was really interesting. I'll give another example to sort of put this into perspective. Let's say a law is passed that where all the cars on the road have to be electric vehicles. We're going to convert all the cars to electric vehicles today, okay? Well, that's going to lower the price of oil for gasoline. So that's going to lower shipping costs, which is going to mean consumers can afford to buy more goods and services shipped from China.
Gotcha.
And so people are going to buy more. Another example, let's say a law is passed where every home is going to get is going to have solar panels, or we're going to install solar panels on every home, and we're going to generate we're going to have home electricity be from solar. Well, then the demand for natural gas and coal goes down at the power plant from consumers, but then factories can then see lower energy costs. So then they can lower the good price of their goods and services, and then consumers will demand more of those goods and services. Oh, great, I can buy more toys for Christmas because I can afford it now. So even that you're just adding renewables into the energy mix. And if you look historically, when you add a new energy source, it doesn't displace the old energy source. We still use the same amount of wood today, a little more than we did when fossil fuels were discovered. You know, we still use the same biomass. So it just adds to the pot. Yeah, it just adds to the pot. So some may argue, okay, well, that's what the COPs are for. The COPs are to bring all the world leaders together to pass a global law that says, do not touch those fossil fuels anymore. We have these renewables. We're only going to use renewables. Let's leave aside the energy return issue. Let's just pretend for a minute. I mean, do we really think that we're going to tell Putin, don't touch that Arctic oil?
Well, that's what I always say.
Don't do it.
And that's why in my opinion, why Joe Biden is going after the Gulf, because they got to stay in competition with Russia, who has the Arctic. So we're going to shit up the Gulf. Sorry, you know, we can say the words on here. But that's exactly what's going to happen. You and I think alike there.
I mean, are we really going to keep playing this cop game and listening to them? And I know people are getting frustrated. Like, I feel so bad for Greta. I love her, and she goes and she gives these impassioned speeches, but But we have to understand what we're asking them to do and understand the economic implications of that to understand that they're not actually going to do that. And I think once we understand that, maybe we can start having a different conversation.
And that's the conversation of what do we do in our lives?
I mean, now the thing is a net zero by 2050, which of course they're still going to emit carbon, but they're just going to plant some trees somewhere and say, okay, it balances out net. They'll plant trees somewhere that then burn down because, wildfires have tipped. So the other idea is, and then another idea is, well, maybe we can force the outlier countries to comply, right? If America, we're the superpower apparently, or, that has been the case since World War II. Maybe we can force other countries to comply, if we elect a government that is leading the way on climate change and to not touch the fossil fuel energy. Well, what do we have? We have a carrot and we have a stick. So the carrot would be economic aid. Like that's what we're offering to some of the developing countries that are really feeling the climate change impacts. We're saying, okay, if you don't develop your economies, if you don't start, using fossil fuels, we'll help you. We'll give you aid. So that's one idea. Then there's the stick, which is economic sanctions. Like, okay, we all agreed that we're not going to touch any more fossil fuels, but this country is doing it, so we're going to do economic sanctions. And then, of course, the other stick would be like military action, war, which no one wants. But the point is that the more countries that disobey the order and extract fossil fuels and use fossil fuels to strengthen their economy, those countries are going to be the ones that can exert the economic sanctions, right? Like if you're a weaker economy, because you don't have a lot of surplus energy, you're not going to have the power to exert that type of pressure to force another country to comply with this don't touch the fossil fuel order. So I just don't see it happening. The last thing that I'll mention that Tim Garrett brings up in his paper is he really does talk about Jevons paradox, which Jevons was a scientist back at the start of the Industrial Revolution in England. And what he found is that England's economic power, and they were the superpower of the world at the time, but that power was based solely on their coal reserves and their coal production. And he found that increases in efficiency to the coal engine and the ability to extract coal only led to an increase in demand for coal. Okay, so efficiency gains just lead to more usage. So I have an analogy for this. Imagine you're living paycheck to paycheck, right? And you're like, oh, I really want to save money. But I just can't because what comes in, what goes out. Okay, but let's say you get a raise. So the idea is, well, if I give you a raise, which you can think of a raise as an efficiency gain, if I give you a raise, then you should be able to save money.
Right.
And that might be true in a world where there's no competition. But what happens is you're trying to keep up with the Joneses. And what do? You spend that extra savings. So you don't end up saving. And so that's really the idea here, is that any species, I think it's called the power principle in evolutionary, in ecology, where any species is just going to use all the energy available to it for its own prosperity, growth, standard of living, etc. Yeah. And so trying to fight against human nature by passing policies that fight against that, I think I just can't see that working out. So I don't know. That's what I have. Definitely look up Tim Garrett. And look at that interview and his paper.
I'll put a link
on that.
to it. Anything, guys, I will put a link to in the show notes. And I am collecting a few questions. Let me see, Phillise, what we've got so far. we might take a little question break unless you want to continue, or do you want to do a little question
No,
break?
go ahead. Now is a great time for a
Okay.
break.
Our new friend T-Bone Side of Life, who I have to give a plug for because he does a phenomenal job on his new channel. Well, his channel on contemporary politics and all of this, and his videography is great. So I'm giving him oops, I lost it. I'm giving him a shout out. But here it is. Oh, I hope I didn't lose it. Anyway, if you guys, I've been sharing his channel. I lost it, and he pretty much was asking about, well, how do we go on? What do we do? But I have to find this specific because I clicked off. So let me get you another question, and then as we're doing another question,
and I'm going to get to that. I can't say I have a great answer for how we go on, but maybe together we can strategize some ideas here based on. I have some things that I think we need to think about in light of all of this.
All right. Well, how about this? This is Poppy. What do you think of Don't Look Up? I know it kind of takes us away, but that'll give me a second.
I did see it, and I think it was spot on, really, sadly. Yeah, I thought it was spot on. I mean,
it was certainly entertaining, certainly interesting.
Yeah.
I can't believe I lost his question. I was so prepared. But yeah.
Well, let's look for it. And so the last two things I really want to talk about is geoengineering, and then what are some things that we should consider going forward. Okay, so geoengineering, I forget who said it, but it really just summarizes the whole idea of geoengineering. Did you want to go with that now, or do you want me
to? It's just I found it, so we're going to make sure I do not lose that again. Okay. So, go for it.
Okay, so geoengineering, you can think of geoengineering as making machines to clean up the mess that machines made. Right? So you're making other machines to clean up the sort of mess that machine has made, which presents a thermodynamics problem. So let me give you just an example of what I mean by thermodynamics. Think of like a perpetual motion machine. Mm-hmm. So imagine you have a robot that's battery powered. The robot has a battery and it's on a treadmill, okay? And the robot is on the treadmill, but the treadmill is charging its own battery. So it's sort of like perfectly circular, where the energy that it creates is the energy that it consumes. And that is a perpetual motion machine, and that can't happen because there's always going to be friction and energy lost from the system. So you're never going to be able to create the energy that you consume this perfectly. And so that's an idea of thermodynamics, and that's the problem that you have with creating machines to clean up the mess that machines have made. You end up really net just making more mess. But let's just take a few of them. Carbon capture and sequestration is sort of like the clean coal. And there are studies that show that it brings down the energy return on your coal so that it's almost no point in burning coal anymore. Like the energy return is really just so low that it just doesn't make sense. So that's why it isn't happening. What about planting trees? I saw a paper come out. There was an article in The Guardian that said, planting trees is the answer. It has amazing potential to solve global warming by sequestering carbon from the atmosphere. When I looked at the paper, it basically said that this study found that we have enough area on Earth to replant trees so that we can capture about 200 billion tons of carbon dioxide over the next 50 to 100 years. And that's all it said.
That's all.
Now, when you see numbers, you have to put that into context. We emit 40 billion tons per year. So what the paper is saying is that we have enough land mass to plant enough trees to reverse the emissions from the past 5 years or from the next 5 years. We're going to capture the emissions from the next 5 years. Mm-hmm. And it's going to take 50 to 100 years to do that. How is that in any sense, any kind of solution? Not to mention the fact that the places where the trees needed to be planted were Brazil, the Amazon, Siberia.
Oh, wonderful.
I mean, they're burning. They're burning. Like that tipping point is already kind of underway.
Yeah.
Go ahead.
No, my real quick was, we do have a follower that is heavy into permaculture. While he doesn't think it's going to be a solution, it's a huge issue, is permaculture, as opposed to just planting trees. So I did want to give him a shout out because he's with us, Rick Larson, and he has a channel too on permaculture. So.
And that doesn't take into account the aggregate. Like if you change all of agriculture to permaculture, and I don't think the yields would support global population as it is right now, just because you need all those fossil fuel inputs and the artificial, those fertilizers and things to get the yields to support. Yeah. But so another geoengineering project that I did look into is the solar radiation management project using mirrors. So I contacted Yi Tao at Harvard.
Well, I want to interview him.
Oh, yeah. So, I asked him for some numbers. I love his idea. I think it's really a great concept, but I emailed him back once he sent me the numbers, and I just add some questions. I really couldn't see how the math was working out. So I didn't hear back from him, but I'll just give you what I found. And then, maybe in a follow-up interview, he may have more updated information. But what I found is that
got an idea.
It would basically, what you're going to do is you're going to increase the albedo of the Earth and reflect sunlight back into space to cool the planet. Now, the problem, though, is carbon dioxide is still going into the oceans. So you still have ocean acidification. So you still will have to decarbonize at some point. But I think his idea is that we can buy ourselves some time and we can mitigate the global dimming. And so this idea of buying time, the idea is that we would reflect enough so that we could stabilize temperatures so that things don't get any hotter, okay? And to stabilize temperatures, it would be $500 billion per year. And that would go towards creating mirrors in the ocean about the size of a state, like about the size of Kansas, surface area-wise, of mirrors. Every year. Not we do it once, but we have to create those mirrors again and again and again. This could be paid for with an annual carbon tax of about $10, which is actually a reasonable carbon tax, $10 per ton of carbon. And again, that would generate about $500 billion a year, okay, thereabouts. If you look at carbon taxes right now, what we've been able to accomplish is the total revenue from carbon taxes is about $50 billion. So we need $500 billion a year, and we're currently getting $50 billion. Now that $50 billion needs to go towards building out all the green infrastructure. So we're going to spend it all on mirrors. Then where's the money going to come from for
it's huge
decarbonization? And we can't even get the reason why the carbon revenues are only $50 billion a year is because that's one of the main things that keeps failing at the COPs is no one wants to agree to a global carbon tax. Like, and then again, it doesn't solve the problem of we still have to decarbonize, meaning we still have to transition to renewable energy, which brings in all the problems that I mentioned before.
Wow. It's overwhelming, actually. It can be.
So there's also direct air capture, which right now is about $600 per ton. Now, mind you, carbon taxes are $10 per ton. So you want to fund direct air capture, which is $600 per ton. The goal is to get that. There's a theoretical goal that they can get that down to $100 per ton, but still.
Yeah. And And then there's not even saying, and I hate to be a naysayer, but is everybody going to have a carbon capture machine on their home? Is it ever going to be something even viable to happen? That's one sphere of thinking and out there in
Well,
the
yeah. Well,
solutions.
right. Put it into context. What we're saying is at the current price of $600 per ton,
Yeah.
that is to sequester all the carbon the world emits in a year, okay, just to keep us even and to stop the planet from warming more, to stop any further emissions, we would have to spend about the entire US GDP. So that's the energy we would have to spend to pull the carbon out of the air, okay? So it's like doubling our energy, and that all has to come from renewables, because if you use fossil fuels to extract the carbon, you actually put more carbon in the air than you extract. Again, the thermodynamics problem.
And then
I'm not seeing that. Yeah.
Store it. There's also storage, somebody asked. That's got to come into the equation.
Oh, storage for
the carbon,
solar, wind energy, or storage. So I did mention carbon capture,
yeah,
and sequestration.
And storage.
I think for direct air capture, in certain places like Iceland, they've got the volcanic rock, and so they push it down into the ground, and there's a chemical reaction with the rock, and it stays embedded. But you're right, if you're not in one of those special geographic locations, there might be additional energy inputs for the storage. And then the last thing I'll say on this is there's BECCS, BECCS, that's bioenergy with carbon capture and storage. And this is something that's really promoted in the IPCC report, especially the 1.5 report. And the problem that most people don't understand is when I told you the IPCC plan, I didn't finish. So the IPCC plan is to cut emissions in half by 2030, eliminate them by 2050. But if we do that, we will have overshot our carbon budget. I think we already have overshot because we've got tipping points going off all over the place. But let's be conservative and go with their numbers. After 2050, we then have to start pulling carbon dioxide out of the atmosphere, meaning that we have to pull carbon dioxide out of the atmosphere. It's not an option to stop us escalating into these tipping points. We have to pull carbon dioxide out of the atmosphere. It's just I'm not seeing a mechanism that meets the scale of the problem. So Paul Beckwith is reading a book right now on all the different geoengineering methods, and he's promised to release a video series on those. So definitely look out for that. He's going to get into the nitty-gritty and the numbers, so I'm excited to see that. But when we watch those videos, we need to keep in mind, we need to ask, is the scale of the solution going to meet the scale of the problem? You know, yes, we can plant seaweed to sequester carbon, but do we have to plant so much seaweed that it has to take up the whole ocean? Like, you know, is it practical? What is the scale of the solution? And I think Peter Wadhams may have a book coming out about that too. He's been talking about that. He's a big proponent of geoengineering because he understands that countries are never going to reduce their emissions. But so far, I've not seen any proposal where the scale can meet the scale of the problem. And you also have to factor in the cost. And then you still have the issue of decarbonization. So,
and you're talking about the marine cloud brightening project.
I haven't seen any
Right.
Yeah, I haven't seen any numbers on that. But I would guess if I did get the numbers, that the math would probably be similar to the Mirror project. Right?
Okay. Yeah. It's a tough thing. I mean, I'm looking at the chat and everybody's like, okay, well, all right, now where do we go with all of these? And of course, the always ever present elephant in the room of overpopulation, or trying to do all this for so many people. You know, which was one of the comments I saw, one of the most recent ones, and out of everybody trying to do geoengineer and do all this for 8 billion people plus.
Yeah, that's really the issue because, and this is what Tim Garrett alludes to, is he says if you don't grow the system, if you don't grow the global economic system, it collapses. And if you have an economic crash and economic collapse, you're not going to have any funding for geoengineering. You're not going to have the funding because you don't have the funding for regular economic activity. You're not going to have it for this extra bit because you have to understand what geoengineering is. It's volunteering surplus energy, not for economic activity, not for profit, but just volunteering that energy to clean up a mess that was made. That's going to be a tremendous drag on the economy because why was our economy so booming? Why do we have this glorious global industrial civilization with all the luxuries and living privileges that we had? Because we use the surplus energy, not everywhere.
As you've probably heard Nicholas talk about.
Right. We've used this, we plundered the earth, we've used this surplus energy and we've extracted the waste. So if we now have to pay for that waste, then there really was no surplus. So it's hard to see the thermodynamics, the math of that working out, where we can actually have the resources to sustain global industrial civilization and on top of that, do geoengineering at the scale that it would need to be done. But that's another discussion.
Oh, yeah, that is another discussion because we're already an hour and 5. This has been fascinating to me to review.
Last thing, yeah, and then the last thing that I have is just a few points of things to consider in terms of how we move forward, because I know our time is diminishing. So if I have time to go over those, I will. I can't say that there are a tremendous number of answers. I can come back. So, so questions or
well,
anything?
let me find T-Bones, and then because that kind of segues into what you were talking about, and he said, so how do we do the work of fighting for the future? Is it just a noble abstraction or a romantic daydream? And that kind of leads into, are we just daydreaming or is it a distraction? I mean, we have to live. We're living. We're functioning. We have kids. We both have kids. So we have to think that way. That's where I'm thinking your motivation comes from.
No, absolutely. And I think my motivation is really trying to figure out, okay, what is going to happen? Not what I wish would happen or, I really want to know, okay, what is going to happen so that I can actually face it and maybe come up with a plan for what is actually going to happen. I think what gives me some peace and solace is sort of looking at the big evolutionary picture. Right? And I know William Rees has some great talks about this, where he talks about us as a species in overshoot, and global industrial civilization is a function of the surplus energy that we found. And as that surplus energy diminishes, or we have an energy production problem and a waste management problem, right? And so one of those two things will come to a head first. We're running out of energy, surplus energy returns are falling, and our waste is threatening our environment and our ability to sustain primarily agriculture at this point. So there's a little bit of an inevitability in that. I think there's an inevitability, I would say, in that we are going to undergo degrowth. Right? The economy is going to shrink, either because surplus energy diminishes, which it is, or because the waste management problem becomes such a drag on the economy that the economy begins to shrink. And Tim Garrett very much is in line with this view as well. So the question is, and this is what we don't have an answer for, is the timing, because there's a saying, c'est pas la chute, c'est l'atterrissage. It's not the fall, it's the impact, right? So if it's a slow process, then there's time for people and systems and societies to adapt to a shrinking economy. So while I don't think voters will voluntarily vote politicians in to enact degrowth policies, we will see the economy shrinking. And depending on how you measure GDP, if you measure it like it was back in the 70s, there's an argument to be made that GDP, it kind of is shrinking in places, depending on where you are. But so I can give just a few sort of dates that I think are kind of interesting as it pertains to our energy production problem and our waste management problem.
Okay.
So one interesting date is 2025, where Art Berman, he is an expert on peak oil and all things fossil fuels. If you want information on that, I recommend that you follow Art Berman on Twitter. He also has a website. And a while back, he predicted that the tight oil fracking, the fracking of oil in the United States, is probably going to peak around 2025. And why is that interesting? Well, because, the first peak oil we had was 1970 in the US, and that led to the dollar almost crashing and sort of the hyperinflation that we're seeing now, right? So it leads to all of this economic turmoil when you have this energy transition. Then in 2005, we had peak oil globally when it comes to conventional oil peaked, and that led to the Great Recession. So since the Great Recession, all of the economic growth that we've seen has been due to the growth in US oil production from fracking. So if that is going to peak in 2025, then the next horizon is the Arctic, really. Now, the EIA, I think, had that peak around 2030. But the reason I kind of agree with Art's projection is because pre-pandemic, we already were seeing signs of a slowdown and trouble. The fields where there was more gas being emitted than oil. The percentage of gas and oil coming out, the oil was going down and more gas was coming out. So they were like flaring more gas into the atmosphere, like 40% more gas into the atmosphere because the oil fields were getting more gassy. And so there was a struggle before COVID. And then after COVID, what's interesting is despite high oil prices, the production in the fracking has not picked up at the pace that experts were expecting. Okay. Now, some may say, oh, it's because there's problems with investment or other things like that. But I think there's a real structural problem because even before you're seeing a lot of cannibalization where they're starting to put wells too close to one another, and they're sort of, and they're having, so even after post-COVID, the oil that they have been extracting, it's due to wells that they had already drilled. They're not really they're not drilling new wells. So we actually could be nearing sort of that peak there, which just a heads up that there could be another transition. And the problem with the Arctic is it's a difficult terrain. The Arctic is melting, but it's hard to put a pipeline on permafrost when it's thawing and melting. It's hard to put infrastructure in tundra when it's melting, right?
They'll find a way.
The weather patterns, the weather patterns are really difficult. So
that's why they're cheering on the melting.
I know. And I don't think that we're going to get that oil up and running very quickly. So I think we could be in for a very difficult energy transition there. That's just something to keep in mind. And interestingly enough, as the oil production problem comes to a head around 2025, also around 2030, the waste management problem is going to come to a head with potentially a blue ocean event in the Arctic. So this is sort of the last sort of prediction that I'll give, but when the 1.5 report came out from the IPCC, it said that you would not have an ice-free Arctic in summer. You might have it once by 2100. That was the prediction. That was from the models, the CMIP5 models.
All right.
The new generation of models, CMIP6, I believe. Well, the newer generations of models are saying, oh no, sorry, that's not actually correct. We're going to have an ice-free Arctic by between 2030 and 2050, regardless of what we do. Even if we cut emissions now completely, we're still going to have that ice-free Arctic in the summer, which in my mind is a tipping point that you don't come back from. But so let's just say as soon as 2030, let's just say we do hit that tipping point. And I know Paul Beckwith has some good videos on this, so I won't go into the science of why that's going to accelerate warming, but I will quote him as saying he expects the Arctic right now is warming about 4 times faster than the rest of the planet. He expects that to jump to 10 to 20 times faster once the ice is gone, due to the loss of albedo and the latent heat effect, the latent heat, all of that. Okay. So what does that really mean for us? That means that the temperature, that means the potential for agriculture loss. Yeah. So when you think the warming of the Arctic, think threat to agriculture. And let me just connect those dots so that we can just keep that in mind. So we know about the jet stream. It's like a halo around the North Pole that keeps all the cold air at the North Pole.
Right.
And that jet stream of wind is possible because the air at the pole is much colder than the air at the equator. However, when that temperature differential is not there, meaning that the Arctic starts to warm, and gets closer to the temperature of the equator, the jet stream breaks down. It becomes wobbly. And that's what's creating these extreme weather patterns that sort of sit and persist. So you have the heat domes in the west, you have the flooding in the east. And why is that a problem? That is a threat to agriculture beyond what the experts were predicting. The experts were predicting threats to agriculture due to rising temperatures. Yeah. And yes, that's true. As places like Italy and Spain, they're losing agriculture due to desertification because of warming temperatures. Yep. Areas at the equator, the crops aren't growing in Central America because of the warming. That is true. But in addition, we've got these extreme weather events that are wiping out, that are really cutting into crop yields, 30% right now, 25 to 30% across the US, China, Europe. Right now, those weather events are sporadic, every few years, every couple of years. But if the Arctic ice goes, there's a scenario where those extreme weather events will become a more consistent thing. And that's where we have to worry about agricultural production. And I think that that's really the biggest threat to that we have. Okay.
Yes.
Another
big one.
Another
big threat.
Yeah. Now, I don't see that happening in one season. Like, we get a spike in temperature and then all agriculture goes and everyone goes extinct within a year.
No.
And for more on that, I recommend Sid Smith. He's a mathematician and leader of the Green Party movement. He has a YouTube channel. He has 3 excellent videos. I also recommend his interview/debate with Guy McPherson on Nature Bats Last, where they discuss the nuclear issue, global dimming, as well as the potential for a complete biosphere collapse. And I'm more aligned with Sid Smith, where I think it's possible that we won't have that depending on the timing, and how this plays out. So I think that the main issue that we have is the issue of agriculture. I think that's the first thing that we're going to see is rising food prices and perhaps some food scarcity. I think that's how global warming is going to impact us personally first.
Yeah. Interesting. Yeah. Wow. Well, I'm going to go to some questions. I don't even know. I've been listening intently. So Well, of course, Rich asked, how many years do we have left, Dr. Todd? And she just explained to you what she thought. And of course, she's not going to prognosticate on, okay, specifically, we're done. No, you're not doing that because, again,
Well,
I think we're going to have another discussion that's going to lead to what do we do for the foreseeable time. I think we don't have enough time to go into that today, but I definitely see the door open for that.
well, I'll leave you with some things to consider so that we can have that conversation. And this is, things to consider. I'm not going to tell you what to do, but these are things that you should consider when you're thinking about your own personal plans. And as I mentioned, local extreme weather. Where you are, particularly like in the US, if you're on the West, it's fires. If you're in the East, it's floods, tornadoes. If you're in the South, it's hurricanes.
Right.
And just being mindful of the fact that those events are going to be increasing with a lot of frequency. And so what is your personal preparedness plan for dealing with that should it become increasing? Do you need to have more mobility, more flexibility, or do you want to think about issues of insurance, and regions becoming uninsurable, those types of things. You also want to think about municipalities, will they have the funding to repair all the damage for hurricanes? So these are just some things to consider. Yeah. Another thing that's interesting is this idea of countries that are food independent. I was surprised to learn that there aren't very many food independent countries. That means a country where if all imports and exports ceased, the country could produce enough food to support its population in country. And the only food independent countries we have are US, Canada, Australia, France, and the former Soviet Union. So Russia, Ukraine, Kazakhstan. That's it.
All right. Well,
So
I'm going to go to questions. Listen,
Okay.
we've been an hour and 21 minutes. We might as well go to the 10-minute, the hour and a half. You cannot have
Sounds
a
good.
discussion like this in a short time. There are
No.
I don't see any really great quality discussions that can be fleshed out in less time. So here we go.
Let's go to questions.
Let's see. I am going to, here's a really nice one from our good friend Goran Halberg. And he says, do you have any role models in science, Dr. Phillise Todd? And I know you've mentioned people that you're following, but do you have any role models from, through your education?
Not particularly, because, we really haven't made any great discoveries in science since Einstein. After that, fundamental discoveries in physics has been lagging, as has technological innovation. It's sort of been lagging. There's a really good book on that called Lost in Math, and it's a real sort of problem right now. In physics. I think it's tied to this idea of surplus energy, but I see everything through that lens. So I would just recommend people to Tim Garrett. I think he's probably at this point the physicist that I'm admiring most, because we really need physicists to delve into the realm of economics. I think that's really needed.
And
so I would definitely recommend.
You've got the background to lead the way, I believe. Yes, you do. All right. Well, thank you for answering that one. And I'll give you let's see. How about Field B? And hers was, has any biophysical economic modeling for Jean Pain, French agroforestry guru who made heat for housing with coiled pipes in big compost piles. This supplies gardens with two. So is this something you have any kind of expertise in, or knowledge of?
I didn't catch the question. It supplies gardens with what? So the compost supplies gardens with fertilizer, or it supplies gardens with
any biophysical
energy,
economic modeling.
Okay, so
French
biophysical So biophysical economics is really Charles Hall, and the economics of
Ah,
energy return on investment. He has a whole textbook on it. And also, biophysical economics, it's really looking at the fact that thermodynamics, the physics of thermodynamics, is at the core of economics. So I think Tim Garrett's work is also going to be in line with that. I don't know if it's going to specifically, I don't know what the connection is with a particular type of local
yeah.
agriculture.
Okay, but
Um,
I do understand this, making the heat in your compost, making the heat within the compost to supply, I suppose, in maybe in a greenhouse, there's compost. I would, I'll look at
yes.
that up.
So
John, the name is Jean Payne, who's from France.
mhm.
That's interesting. Thank you, Field B. We will definitely look that up.
I think the issue is maybe using it to provide energy for your home. You can have a compost bin, and then the off
Ah,
gassing, that gas, you can use that gas to
okay.
actually cook your food. You can use it in your home. Again, the issue
Yeah.
is the scale of the solution doesn't necessarily match the scale of the problem. And what you find is that I've seen people doing this and they just didn't have enough compost. They
I
just didn't
got you.
produce enough waste to get enough useful energy to maintain anywhere near their lifestyle, even with a reduced energy budget. Sort of like in Planet of the Humans, where this idea of, oh, we can run the zoo on the energy of the waste, the poop that the elephants
Yeah, redo it. Just
but but they didn't make enough of it to heat the cage. Like they didn't make enough of it. So it's always that's the issue of scale there.
that makes
Yeah.
sense. Definitely the issue of
Mhm.
scale. Ah, let's see. Patrick McNulty wants to know if you've ever heard of his ocean mechanical thermal energy conversion.
I haven't, but if you want
Okay.
to send
There's a
it to
video.
me,
I'll send you a link. I interviewed
yeah,
him a
awesome.
few years ago, and so did Dave on Just Have a Think. So we'll get you that.
And
And
any solution, you need the numbers, like you need the cost and you need the scale of the how, what the
yes,
numbers in order to think about it intelligently,
you're how about this one?
one more
Oh,
thing
go ahead.
I'll
Go ahead.
say about
Yes.
the I know a lot of people's strategy is to, and I hate to bring this up, but a lot of people, and this was my strategy, is well, I'm going to grow my own food. That's going to be my
Good.
solution. I'm going to have my own garden. I'm going to grow my own food. We're going to have small local gardening communities. Everything's degrowth. We're going to go local. The only problem with that is if we lose agriculture due to extreme weather events, I think we're going to lose it also for the small scale farmer, right? Because
Well,
you
yeah.
and your home garden, you're going to be subject to those same weather extremes.
Yes, I was
So the
this
point,
year.
right? So the
Yes.
point is if you're dependent on your own garden or your local garden community for your food, and then you have repeated severe weather events, you're kind of going to be in the same situation as we will be globally. So, you know, the idea that we're going to revert back to an agricultural society, I don't think is quite right unless we're using a lot of fossil fuels to do like underground aquaponics, and there you won't have
Oh,
grains or meats. You'll just have vegetables, really.
right.
You won't really have a lot of, and that would be very expensive food that maybe the elite will have. But I think the rest of the population may actually revert back to hunter gatherer type society. I hate to say that, but if we
It'll
lose
be a very
agriculture,
small population, unfortunately.
ugh,
And
I
we
hate to
don't
say that.
of course we hate to say that because
Yeah.
we have kids and there's people out in our audience that have grandkids and kids and you cannot dismiss the fact that we think about them. I think about
The
them
only
before I
grace
think
that
about
I can
myself.
offer, the only grace I can offer is maybe check out Sid Smith and just the timing. If we
All right.
have time to perpetuate, to keep this set of living arrangements, as Guy McPherson likes to call it, going, I don't see it collapsing or ending overnight. Let's hope not. And then in the meantime, we can begin to adapt to the changes as they come.
Okay, let's see. How you guys doing out there? I
That's
had
all I
oh
have. Yeah.
Okay. Humans breed to the limit of resources, always have and currently are doing so. The green revolution in gasoline has set the Malthus trap higher, but we are almost there again. That's Hoople's cat. He also has a channel. He is kind of a prepper channel. He's also now living way off grid and very interesting person. What do you say to
I
that?
love that. I love that. And I think that's the key is, you know, if global industrial civilization begins to contract due to the reduction of surplus energy, due to the high debt, due to just the global system itself, the last quote I'll leave you from Tim Garrett is that at the current growth rate, we will need to double our consumption of energy and resources in the next 30 years. Double. And so
Really?
there's a very good,
Wow.
yeah. And so there's a very good chance that we won't be able to extract that amount of energy out of the Arctic if tight oil is peaking in the US, is what I'm saying. It's very likely that we may not be able to meet that pace of growth over the next 30 years in energy. And that would be a good thing because it will force degrowth, right?
Yeah.
And maybe if we're in a forced degrowth over the next 30 years, maybe we might not trip as many of the tipping points. So that's the last positive note. The last positive hope that I will give
Positive.
is that we don't even know if they're going to economically be able to extract the resources in the Arctic. And the resources that they're extracting here in the US, the fracking resources and tight oil, are coming to a peak. So if that were to peak and we couldn't get the growth from the Arctic oil, then we're going to go into economic degrowth. And yes, it's painful, perpetual recession, but if that happens slowly, societies, people can adapt to that slowly, and we won't double our consumption of energy and resources in the next 30 years, as Tim Garrett suspects. And if that's the case, maybe we'll stop tripping so many climate change tipping points, and maybe we can come to some sort of climate stabilization because we'll be forced to decarbonize because we can't access the oil. So I'm glad I found
A
some
forced.
positive note to end on. And we just have to stay tuned for that and
I
look
I
out for
think
that and see where that goes.
I think that's a good place to end. I have a lot of comments. The chat's very busy. But it is time. I have, guys. I don't know if you were here in the beginning. I had my neck brace on. I'm just in like the worst painful situation right now, but
Oh,
I'm here and I'm with Phillise and I've enjoyed the conversation immensely. And I would really like to have you back to flesh out more of the discussion on what we just talked about. It's not the hopium or the apocalyptimism or any of that. It's just the hard facts on how we're doing it, how we will be doing it for ourselves. And you bring up, and I do like the fact that you bring up uh, um, the issues of expending more energy and growing food, because I know it was more expensive, I think, for me to grow what I grew with what I needed to do than buy it, However, maybe this year it won't be as bad, but we got torrential rain. So, everything, I saw it all. Torrential rains this year. I've seen it all. I'm living through it.
wow.
So I want to thank you. I want to thank Hoople's cat, Jeffrey, C. Michelle Sparks. I loved having you here. I have met people in other chats, and they come and they come in, and if I could just bring like, even if a chat has hundreds of people in it, if I could just bring one person into the show and enlighten them with what we do here, and we don't try, like Poppy was, she says she doesn't want to end on hopium, and I don't think we're ending on hopium. It's pragmatism. We have to be pragmatic here. We're alive, and we have to figure. And Phillise, you're very helpful in helping us understand on a level that is we can grasp. It's not over anybody's head. Now we have a very educated chat. However, not all of us are educated in everything. So this was great. Thank you so much. Guys, thank you, Jean and Kameshwari, Kate, Boomer, you. I'm going to end like I usually do with some music. Phillise, you will be back. Oh, I am completely hopeful you will be there. We're ending on an up note. I'm hopeful.
Yeah. Okay.
Phillise is coming back with me. Yeah, because I absolutely love this. And I would also love to see you come in with the team and see have a conversation with, I think you'd probably really do well with Antonio. Or even Jennifer.
Oh, he's great.
Yeah. So
you guys are all great. So
this is I think this is the beginning of something. So thank you. Thank you guys.
Thank you.
And also everybody, thank you for your contributions to Buy Me a Coffee. It's amazing. All right, guys. Good night.
All right.